Okay, and then I will write as every time, okay? So what is this lab is talking about? This lab is a continuation of the lab that you supposed guys to be finishing by today, or you can take your time. There is no problem. So do you remember, we have a counter, right? This counter has a clock and it has a 4-bit output, right? And it has reset and it has up, down, or BCD hex, right? Up, down, BCD hex. And it has enable, if you remember, right? It has enable in and it has enable out. And that was 1 unit inside it was 4 consecutive units connected to each other, and those 4 connected to 4 digits. That's true? That was lab 4, if you guys remember. Now, lab 5 is much simpler. Why? Do you guys remember? You guys work with assembly, right?
Yeah, for those of us, is the PIC 18 class prereq for this?
Yeah. So, have you guys heard about jump? Have you heard
Yeah, that
about instructions called jump?
yeah, that's where like when it calls that section, it like
It will go
goes
to
up
that
to
line
the
in the instruction memory.
yep.
That's correct. You know what is this? It's a counter. One second. It is a counter. So jump 100, what does it mean? It means that, whatever you are at, add 100 to it and go to it. That's basically what does it mean, right? So if I want to make it in C, right, I'm gonna do it. I'm gonna assume that C in T, it's a variable and it has 0, correct? It's starting from 0. Then I will say C in T equal C in T plus 100. Correct? This is not correct. Supposed to be there is something called load. Something is called load. So what does it mean? Here is my counter, right? I have a 4 outputs, 4 bits, and I have my up, down, and I have big BCD hex, and I have a reset, and I have a clock, right? Now, I can also have a signal, it's called what? Load. Load what? I will have an input 4-bit. Those 4-bit, I will load them inside the counter. So how this will look like? So imagine that, when I push reset, right? The output is called CNT, right? And when I push reset, what will happen from your point of view? I will be resetting what? The output, right? If it's if this is up counter, then the reset, it will make this guy what? Starting from 0, right? No matter gonna BCD or hex. You guys agree? But if I push reset while, for instance, the down counter, then I would start it from if it's hex F, if it's BCD, I'm gonna start from 9. Does make sense?
Yeah, that makes sense, depending on if it's up or down counting.
Exactly. Now, with load, I will do something interesting, which is when I say load, I will bring the internal of the counter and I will load it with the value written in this. So imagine I wrote here 100. So I'm saying what? When load happen, put 100 in CNT, and then when the load is released, I mean, you move the button, you moved your hand from the button, right? I will be what? CNT equals CNT plus 1. So that means the next is going to be what? 101, 102, and so on. Does it make sense? That's if it's up counter. If it's down counter, it will be the time that I will remove my hand from the load, it will be 99, 98, and I continue. How are we going to do this from your point of view? It's too simple, right? So I'm going to make it as an example for up counter, but the rest is easy, right? So if I would like to create a counter, do you guys remember how to do? Don't worry about, this module is starting, but we're going to start from temp, right? So if I say rig 3 to 0 temp, that was my temporary because I cannot use the output, correct? Then I will go ahead and do what? I will say always block at positive edge of the clock. Then begin. Then the end. The end, it will go somewhere here. So what is the priorities of signals? We have a bunch of signals, right? The example that I'm writing, I'm gonna consider it up counter. I'm not gonna even bother by its up BCD or hex because I showed you up BCD or hex before. So I will just go ahead and say if reset. When I write it, that mean if reset is high, right? So that means temp will start by 0. Else what? Else that mean if this reset is no longer high, it's low, right? Then I'm gonna containerize it with begin and end because it's gonna be a several lines right in here. Correct? Now I'm gonna go into what the priorities. What is the priority we have? We have enable, we have load, whatever we have, right? If we have enable, so now let's draw how this counter will look like. We set it up counter, so that means we know that's an already up counter. So we have a clock, we have reset, and let's say we have enable maybe, and we have the 4-bit input, and we have load. That's 4-bit, and this is 4-bit. So in that case, reset is done. Clock is here. We need to talk about the input, the enable, the 4-bit input, and the load. How we're gonna be sorting them in the code, right? So since the reset is no longer high, so the second it will come the enable. So I can just write here if enable, and I close the brackets like this. That means if the enable is high, something will happen, right? What this will happen. So perhaps in that case I would start looking into what is the rest and in the list of the signals for controlling this circuit, right? So what is the list? It's actually load, right? So in that case, enable, I'm gonna write under it begin and then end under this. So what will be under this? If enable is high, okay, and load is high, load will be working. Do you guys agree? So in that case, I would say what if load is high, then I'm expecting what from the load to be high? I'm expecting to be temp equal input. This is input. But if load is not high, else what will happen? It will be temp equal temp plus 1. So did you see here I didn't use begin and end, right? Because I know that there is not that many to execute because of, do you remember the blocking and unblocking thing that I mentioned to you before? So by if I look into the execution of this, I will find out that if the reset went high, automatically this circuit will perform 0 as an output. But if the reset is not high, I will start looking. If my enable is high, I will see That means the circuit's performing, but performing what? If the load is high, then, automatically I would put the input as an output, as a state, as an out, I'm defining the current state by the input. But if the load is not happening, but the enable is high, that means I'm incrementing on whatever that load happened. Then, to close this, of course, what is the output here? Let's call the output here CNT. So pretty much going to be what? Assign CNT equal temp. And of course, you're going to close your module, whatever. What I'm saying makes sense to you guys?
So far, so good.
Okay, good. So this is how the circuit's supposed to be performing, at least for up counter. And pretty much when I say up counter and 4-bit, that means gonna be hex, right? Because again, 4-bit, the minimum is 0, the maximum 15, which is F, right? So this circuit is performing hex for sure. Okay, look. Now architecture, like higher level, how the higher level will look like. The higher level is simple, right? Before the higher level, let's actually decide, because some of you guys sometimes ask me about, how many switch, how many buttons, all of this, right? From your point of view, we said it's supposed to be what?
Like in its default state while it's running, is that what you're asking?
No, I mean, should I use switch or LED or buttons to
Oh,
present?
the button
Yeah, why button?
to get a just momentary input instead of just like a toggle
Exactly.
switch where
You're right. It's button. Okay, clock is clock, right? Enable is supposed to be what?
that one's a switch.
It's supposed to be switch. Why? Because I turn it on and I want the thing to be running, right? So I don't care that much about the moment, right? I don't care about the transition basically. Okay, the 4-bit input will be what?
Another series of switches.
This will be switches, right? Correct. Then the load, it will be what?
Would that just be like programmed in, or do you also want that to be through switches?
It's up to you. I mean, think about it. The load is supposed to be switch or to be button. What do you guys think?
I suppose if the load never changes, you could just have it
It will be switch
programmed
forever.
in. Yeah, and then you just press the button for the load enable.
To be honest, load, it has to be button. You know why? Because you're just changing the current state, and then let the counter do whatever he wants. You agree? So if I use the 4 switches of the input to draw what is input will be, then I push the load button, I just load it. Then I release my finger from the button, then it's continuing going up or down, whatever, right? Does make sense? But if you make it mechanical input like switch, then you're gonna be stuck until you change the state of the switch, right? You agree?
I get what you're saying.
Makes sense? For the rest of you guys, that makes sense? Hello? Is anybody here? Okay. Ryan, give me a thumbs up. Okay, thank you. Now, if I want to look into the final architecture, so we're gonna have a 4-digit as before, right? One, two, three, 4, right? Then we have here counter 1, counter 2, counter 3, counter 4, right? So all of the reset will be the same reset, same reset. All of the enable will be the same enable, Okay, now we have, let's have a different color. So the inputs of this is gonna be the same input here, same input here, same input here. So that's a 4 switch. Then we need up, down, whatever, right? So maybe we can have a different color. So they're gonna be, you know, all of them will be up, down. And, you know, we need different color. And they're gonna be what? Hex, BCD hex. Correct? And of course, you know, they're gonna be what? Connected like this, 4, 4, 4, 4. And definitely the clock, it will have also the, do you remember the speed? The speed thing? The speed thing ain't gonna be a big mess. You guys agree? We have a big problem here. What do you guys think about? You know what's the problem we have? No, we don't have that much problem, actually. I'm wrong. You know, because, you know, how many switches we have? 4, 5, 6, right? So we have 6 switches so far, right? 7 is a switch, right? Then, you know, so we have 7 switches. Then, you know, how many buttons we have? We set a button, it's 1. Then, you know, we need maybe load also, right? So we have 2 switches. No, 2, sorry, 2 buttons. Okay, then if you still remember, right? Do you remember the speed counter thing that we created, which is a counter with 5 switches and stuff like that? Do you remember this one?
Right.
Yes.
Yep.
So yeah, we need what? We need the 5 switches still for what? For controlling the. Let me just get you a different color.
Yeah, for the clock divider.
Yes, sir. This is the clock, right? The clock, it has the box of the original clock coming from the XDC, right? Which is 100 megahertz, correct? And then it has a reset, and it has 5 switches, which is those actually, for controlling the speed, right? What is internal circuit here? If you remember the internal circuit, it was a multiplexer like this. It has 5 switches control. This is the output here. And then, you know, 32-bit counter is counting with the clock and the reset, and it's up counter. Correct? Any questions so far? So somebody will tell me the reset. Do you want to use the same reset? It's up to you. You could actually use the same reset. Still, you know, we have 5 buttons, right? Remember, it was like this, right? 1, 2, 3, 4. It was like that, right? This is how it looks like in the board. Correct? So, you know, we have 1 for enable. Maybe we have 1 for reset here. And, you know, if you want to have 1 more, you know, it's up to you. 1 enable. No, you don't. I'm sorry, not enable. They're gonna be load. They're gonna be reset. And maybe 1 for the reset for the display. Display. Reset. And then, you know, enable is actually, enable is what? It's a switch 1, 2, 3, 4, 7, 7 plus 5, so we have 12. And you know, in general, how many switches do we have? We have 16s, right? So we utilize 12 out of 16. That means there is still 4. Leave them for now. We can use them later in the future. Is the experiment is clear? So what we need to build again, it's gonna be the same structure that we are building in Lab4, but we're gonna make it what? Load counter. Okay. And for grading this, same thing. I think all of you guys actually feel more confident by loading your stuff in GitHub. So it's gonna be 50% on the test bench and 50% on what? On the demonstration recorded video. And also don't forget, if you made you work by yourself, appraise yourself. I mean, why you have to share with others if you think that other didn't do? End of the day, you are paying to learn, right? It's not making in favor for somebody. Do you guys have any question before I write a bunch of lines for you as I did last week? So I can put it on the what's called. I can put it in Discord. Any question? Any concern?
For the I guess for the load, that's just whatever value we determine it to be, right?
The load is gonna be a switch, right?
But
You mean the value
value of
written
it.
in the for input? It's up to you.
Okay.
Yeah, it's demonstration. You can try in front of me multiple numbers, right? I will give you a very tricky question. Imagine that the circuit in front of you here, deal. You make it up BCD. Did you hear me? It's an up what? BCD. But then you put in those 4 switches 1 1 1 1 1. What will happen? Don't forget, this circuit is the same as before, right? Enable in is enable out, enable in, enable out, enable out. Enable in here is gonna be fixed number, it could be 1, and that's it. And then the previous enable here gonna be ended with this. This one is ended with this, and this one ended, and so on. What does it mean? If I put here F, but those guys programmed to be what? Up counter, BCD, I'm not gonna see F. But don't be afraid. You know why? Because end of the day, if your circuit up here doing the job correctly, it will fix itself correctly. You understand what I'm saying?
Right. It should automatically roll over.
It should automatically will actually exclude the F. It will kick it out. So you don't need to put it now in your consideration and scare yourself, because automatically it will be fixing itself. If it works by itself, which is mean the Lab4. That makes sense? Any question? Now, if there is no question about this big drawing mess, I will start sharing my other screen so I can write on Discord, because I know you guys prefer Discord too, right? Can you guys see my Discord?
We still see the tablet screen.
Okay, let's see.
Oh,
now
there it goes. Yep.
Okay, Lab5, right? Focuses on incrementing the circuit growth of Lab4, taken in the consideration the following. Each BCD hex up down counter will have the ability to receive the current state value using loading mechanism, which means the counter will have 4-bit input, 4-bit output, reset, load, enable, up, down, BCD hex, control signal. For counting number of switches will be used, we are going to make all of the 4 counters in the Lab4 having the same 4-bit input, and by then we will end up having what? 12 switch in total to be used for this experiment, while 2 to 3 buttons will be used. Grading, as you all prefer loading your work due to the constraint environment. 50% will be for the demo and 50% for test bench. Be sure to distinguish who did what, as even you are working in a team, you need to learn individual. Sounds good? Do you guys have any other problem, any question, any concern? Do you want me to clarify anything? Everything's okay? Hello?
Seems good to me. Like I said, I'm still trying to work on my Lab4, but
Take your time in Lab4. There is no rush. You know, the most important thing for me is the result. Plus, you know, we still have a couple of weeks, right? So you are fine. We're supposed to have 2 more labs or something like that. Any question?
someone asked in chat if you can clarify once again the extra buttons, what they're used for.
Sure. One button for load, one button for reset, one button for display reset. But if you want all of them sharing the same reset, then one button will be enough. That's why I go to 3. Cool. Sounds good. Also, a copy of this recorded video will be loaded on YouTube, and I will load it. What? Be sure to watch the recorded session. This Okay, look. What other questions you guys have?
Professor,
Yes, sir.
in your normal semesters, I've had friends that have taken it, and at the end of the term, you have like a project that you make all the students do, correct?
Yeah, but in summer I don't do that. You know why?
Why?
Because the summer is 10 weeks, but the semester is 15 weeks.
Hmm.
But of course, I love projects. Do you want to go for projects?
Uh, well, I was just curious. I don't know how like, my feelings are towards it. I mean,
My whole entire work is based on projects.
Hmm.
But the problem was if you notice, right? The problem is they make it asynchronous and synchronous and stuff like that. But if we're in campus, I will give you projects.
Okay.
Make sense?
Yeah, because I was interested in doing a project, but I didn't know whether like to wait till the end of
Just
the
come and
term.
work with me in the project. I will give you
Okay.
a big project. I have actually a project I would like to finish, but I don't have time. It's about true random number generator. We are using the radiation coming from the electronics to build random number.
Hmm.
So just let me know and I will give you the detailed information about it.
Okay.
Okay. Huh. I see some people in the chats. Let's see what they want. Can you clarify what is the extra buttons are used for? I think I did. Okay. What else? Okay, now maybe we can ask actually a random question. So how many of those people are attending today in favor of having project? Do you guys like to work in a project? You can raise your hand. Do you know how to do it in the chat? If you want a project, raise your hand. I don't think not that many people, not that many people interested actually. Yeah, Brandon doesn't like. Okay. Any question? Somebody text me. Let's see. Okay. Raymond, I'm asking in general, do you like to do a project? It could be actually counted on your on the course, not in the lab. But I see all of you actually attending both, right? How many labs do we have left? Is it just one per week until the end of semester? Calvin, it's supposed to be like that, but because I'm gonna add like one lab, it will maybe take 2 weeks, 3 weeks. So it might end up actually having like two more labs. Any other questions? Do you guys have any problem? Do you want me to solve any concern? Okay, in that case, God bless you guys. Please stay safe. Your grades will be loaded on the system. I think some people actually asking me for like delaying because the holidays and the 4th of July and stuff like that. That's why I didn't post everything. But I'll be posting them, and also I'm gonna be start working on grading your first midterm. Sounds good.
All right, thank
Yep.
you.
Thank you guys. God bless you. Stay safe.
Thank you, Professor.
Thank you. Bye bye.